welcome to day 2 of the IChemE Student Summit, yesterday, today and tomorrow. We'd first like to acknowledge the traditional owners of country throughout Australia and recognise their continuing connection to land, waters and culture. We pay our respects to elders past, present and emerging. My name is Emma and I'll be emceeing today's session along with Antonia. The video and microphones of all attendees are blocked for this session, so if you're having any technical difficulties or have any questions or comments, please send either Antonia or myself a message through the private chat on the right-hand side of your screen. And please post any questions for our speakers during the session in the Q&A panel on the right-hand side of your screen. So the theme of our session today is on resources, and we'll be starting with a panel discussion on the water industry. This will be followed by 3 lightning talks from experts in the resources industry, and our speakers will then come together for the Powering the Nation panel. So joining us to discuss the changing flow of the water industry is Daniel Bonini, Contract Manager at South Australia Water, and Dr. Annalisa Contos, Founder at ITM Consulting. To start off this Q&A, could you each please introduce yourselves and tell us how you found yourselves in the water industry?
Okay, I'm Dr. Annalisa Contos. I'm a chemical engineer. I've been working in the industry for 20 years. In the last 10 years, I established my own company, ITM Consulting, and we've grown the company to provide water solutions and operational knowledge, supporting communities to deliver safe water and sanitation services to their communities. I found myself in the industry through luck as a graduate and absolutely loved it. It's an industry I'm really passionate about, and it has, I've loved as I've worked through it and grown to understand the benefits that water and sanitation is delivering for our society.
Yeah, my name is Daniel Bonini. So I work at the South Australian Water Corporation here in Adelaide in South Australia. I graduated from the University of Adelaide with a Bachelor of Chemical Engineering and a Bachelor of Finance. And I've been working at SA Water for almost 7 years now. I guess I came to be at SA Water through a graduate program similar to Annalisa. I've worked in a number of areas in SA Water across water quality, asset management, wastewater process engineering as well. But in recent years, I've found myself in the outsourced operations side of thing, in the commercial contracts, and so I currently manage the operations and maintenance contract for the Adelaide desalination plant, which is our main desalination plant that supplies metropolitan Adelaide. Similar to Annalisa, I guess I really enjoy working in the water industry. I think water is a vital resource. Both for domestic use and also agricultural use, and yeah, really glad to be a part of its supply, its safe supply.
Awesome, thanks Annalisa and Daniel. So obviously we've got quite a varied experience between the two of you, which is good to share some knowledge to us young professionals. We're going to jump into the sort of set panel questions now, but just to remind all the attendees, if you have questions throughout, drop them into the Q&A section and Emma will filter through them. So just to start off, obviously you've both shared your love of the water industry, but I was wondering if just to start, you can share some maybe challenges that either you personally faced or that you can see the industry facing as a whole currently. And maybe Annalisa, you can start with this question.
Sure. Before we talk about the challenges, I think it's important to get some context about the industry. So in 2018, the water sector in Australia had a revenue of $23.5 billion and it employed over 28,000 people. So it's quite a significant contributor to the industry. We've heard a lot recently around aviation, and yet water in a lot of ways is very significant in terms of its contribution to the broader society as well. One of the real challenges that we have is our industry owns and operates assets with a combined value of over $160 billion. So asset management is a real challenge. An estimated 60% of those are underground, so there's pipes and pump stations. Now, you think about the inconvenience that you experience when there's roadworks and it's really hard to get round. So maintaining these assets is really challenging. We want to extend the life of them, but if we get it wrong, you end up with craters in intersections or washing away people's houses. And there's plenty of amazing footage on YouTube if you want to go looking for what happens if we get that wrong. Obviously, climate change is having a huge impact on the industry. We're seeing not only longer, but actually deeper droughts. So Daniel mentioned his role looking after the desalination plant. So we're moving to climate resilient supplies, which is easy on the coast, but it is harder inland. Another challenge that we have, particularly as engineers, is to shift our thinking away from infrastructure and processes and moving much more to what it is that we're offering. So as well as the public health benefits that we get from safe water, water's adding $14 billion to the Australian economy. It's a key input to the well-being of our communities, and it sustains blue and green spaces. The lockdowns have really drawn our attention to how important it is to have the local parks, the fountains and the waterways for passive and active recreation. So moving forward, one of the key challenges I see for our industry is engaging and being engaged in discussions beyond our industry and out so that we are delivering those livability benefits.
All right, thank you, Annalisa. Daniel, did you have anything you wanted to add on the challenges that sort of face the water industry?
Yeah, look, I think Annalisa touched on some really big ones there, but I guess and her comment about climate change and I guess its impacts on water scarcity is probably, I see, one of the biggest challenges we have. You know, we've seen the Millennium Drought. We've now seen the beginnings of a similar drought across last year and into early this year as well. And so one of the biggest challenges for the water industry is how we deal with that scarcity and what alternative sources do we look to. You know, in my instance, I've had a lot to do with desalination, but you'd be hard pressed to go to a water industry conference or panel discussion to not hear the direct potable reuse question brought up as well, which in layman's terms is basically recycling wastewater for another use, be it potable use or some other recycled water use. In many ways, that can from an energy point of view, and I know we're going to talk about energy a little bit later, but direct potable resource is a less energy intensive option than production of drinking water from seawater. But it has associated a number of perception issues from customers and the public around can it be done safely, and poor messages that have come out in the past around toilet to tap and horrible phrases like that. And so I think as an industry we need to challenge those perceptions. As engineers, we have the means by which we can produce safe water doing that. But it is more of a perception issue that we have to continue to work through to be able to deal with that scarcity. Increased customer expectations as well, I think, is another thing of the water industry itself. So customers are seeing their energy retailers provide them with smart electricity meters. More online functionality with billing and usage, etc. We need to move towards that in the water industry as well, and there's an expectation on us to do that and be more than just simple utility provider of essential services.
Right, so it sounds like we've got the water industry as something that's quite innovative. So that sort of leads to our next question quite well, which is sort of focused on research and development. So in your, I guess we'll start with Daniel, in your sort of experience, what do you think are the main areas of research and development in the water industry? And if you can maybe also add on what sort of excites you about what's happening in the water industry now?
Sure. I think always, certainly in the drinking water side of things, and also on the wastewater side, the constant challenge to meet ever more stringent water quality regulations is an area where research and development is key. Certainly, even in my relatively short time in the industry, we've seen changes in what's required of us as a utility to produce safe drinking water for our customers, and also return water safely to the environment and water for reuse purposes. And so, keeping abreast of the technology that's required to meet those requirements. Again, we have that technology there. You know, in the last 20 years, we've seen big advances in things like ultrafiltration, reverse osmosis, UV treatment of water. But those things are energy intensive, and so we need to continually work to bring the cost of energy down for those technologies. And R&D, I think, will play a big part in delivering that. I think, probably going back to the previous question, I think research is also going to play a key part in that question of treating water from more variable sources as well. As our surface water supplies dwindle, and our certainly in Adelaide, our River Murray reliance, we may not always have that source of water available to us. We need to look at ways we can treat sources of water that we may not have considered in the past, and evaluate what's available to us to actually do that.
Thank you, Daniel. Annalisa, did you have anything you wanted to add on to that?
I think the industry is a really innovative industry. There's a national organisation that is supported by the utilities and consultancies and universities called Water Research Australia, and they're very effective about going out to industry and finding out what needs to happen with the utilities and other organisations, and then bringing the researchers in so that we're getting very efficient and effective research. And what that's seeing is Australia is world leading in a number of areas of research. We've certainly got some, as Daniel mentioned, the emerging contaminants, so microplastics, nanomaterials, PFAS are really challenging for our organisations. Australia also faces a lot of challenges with cyanobacteria or blue-green algae. So how can we manage that effectively and efficiently? How can we remove it? We tend to be a very conservative bunch, so how can we be more efficient and manage with more certainty? So there's a lot of opportunities to understand more and to operate our systems better. I mentioned the asset management challenges. So how can we do more with less? How can we take our old infrastructure and meet these higher standards, particularly with the emerging pathogens? How are we managing things like cryptosporidium and getting rid of that effectively with old infrastructure? And then looking beyond our own industry, and very topical at the moment, there's both national and international research that's looking at the tracking of SARS-CoV-2 in wastewater, which is the virus that causes COVID-19. And the research there is looking at the role that can play in public health surveillance, so supporting the test and trace efforts that we're seeing on the surface through the public health officials. But can we also find out where we're getting those community transmission and small outbreaks occurring before that's being picked up by the public health surveillance? And there's certainly evidence that wastewater tracking can deliver that for us.
All right, thank you both. So we've already heard issues of climate change being mentioned a couple of times so far as something that affects how we operate in the water industry currently. And Daniel also mentioned the cost of energy also being a big factor in some of the research and development that's going on at the moment. Could you both comment on what you've observed so far in terms of renewable energies, and if those are sort of starting to transition into the water industry, or potentially if engineers in the water industry are working with renewable energies? So I guess we'll hand that to Daniel first to start off with that.
Sure. Look, I'm gonna be a little bit selfish here and talk about one of SA Water's major initiatives, but I think it sort of exemplifies the issue we're discussing here. So we're currently embarking on a $390 million program to install around about 500,000 solar panels and 34 megawatt hours of battery storage across our sites. Now that's a project we're undertaking not only for the environmental benefit, but also because it's very cost effective for us to do so, and it's going to have a very quick payback period. In South Australia, we fluctuate somewhere between the second and third top energy user in the state. I was writing down the figures before. We use something like 520 gigawatt hours of energy per year, and so as a major energy customer in moving around water around the state and treating it, by installing our own generations and storage assets, energy storage assets, we can play a significant role in both bringing down our cost of energy, but also making that transition to renewables. We participate in the wholesale energy market at SA Water as well, and so that's something that we've moved to because big energy utilities like us, I guess, have an ability to curtail our loads and optimize our energy loads at different times of the day, and so the introduction of our own generation and storage assets was our natural progression to actually introduce generation, not only a demand response to energy, but a generation response as well, to produce low and stable energy prices that flow onto our customers as well.
Annalisa, anything to add to that one?
Yes, I think expanding on what Daniel said, electricity is often one of the top 3 operational costs for a water utility. The sewage treatment plants can typically account for about half of the energy used to deliver the water and sewage services. So as well as looking at renewables, the industry is also obviously seeing great benefit in terms of looking at energy efficiency as well. So that's delivering something from both a cost and a carbon footprint perspective. But coming back to the shift to renewables, we're definitely seeing that in both energy generation and energy recovery. So both the clean and dirty side of the industry have done a range of projects to recover energy. So almost anywhere where there's a decent amount of head that needs to be dissipated now has a little mini generator on it that is just recovering that energy as the waters come down the hill rather than just letting that go. On the sewage treatment side, we're seeing more and more recovery of that carbon that's within there in terms of biogas. Certainly over in Europe and America, there are some really big projects that actually bring in additional carbon sources so that you're really producing your biogas generation. As Daniel mentioned, many projects are converting to solar generation. So I was involved in one recently where they put in the solar panels, but they also designed the plant to operate in 2 windows. One was peak solar production, and then the other being the low off-peak power, so that it leads to a slight increase in the capital cost, but a much greater reduction in the across the life of the plant in terms of energy And then if they ever need to, they can also ramp up the plant a little bit more. But the design philosophy of that was actually to operate in the 2 windows. And a final example, which I think is really interesting, is at East Lismore sewage treatment plant, where they've actually installed floating solar panels on one of their lagoons. And I think that sort of innovation will become very interesting, where again, we start to see that potential for solving those wicked problems. So we can generate power, but then we can also stop algal growth on the lagoons. So we're not there yet in terms of that one, but there's certainly some really interesting possibilities for looking at how we can both generate energy, but also solve some of our other problems.
Awesome, thank you. That's quite interesting to hear about floating solar panels. It's always good to hear engineering working with nature rather than against it. Just for my own curiosity, I had a question that maybe Daniel can talk a bit more on in terms of the operating side. We've touched on quite a bit of sort of those offset technologies with solar and those sort of technologies. But in terms of from an operations side, do you see the industry, like is the day-to-day operations sort of reflecting that urgency that climate change sort of brings? Is there more of a attitude towards efficiencies and increasing the overall sort of environmental impact of the operating plant?
Yeah, look, definitely. From a water utilities point of view, I guess aside from the generation of green energy that I've just talked about, energy efficiency is a big part of our initiatives as well. Like Annalisa said, certainly I've been involved in some energy efficiency programs at wastewater plants. As Annalisa said, that they can be some of our most energy hungry assets. And so where in the past some certain set points across the plant or certain equipment might have been set and forget, that aerator is doing its job. It's feeding our bacteria. We don't need to touch it. We've done big audits of all our major plants to see what are the most energy intensive parts of the plant, and then what can we do to optimize those key unit processes to reduce energy usage. So whether it be intermittent use of those pieces of equipment, whether it be installing a variable speed drives to allow greater turn down of that equipment, where it hasn't been sized correctly, things like that are now again not only for the environmental benefit but also for as an operator, the cost of energy you'd be silly not to. So yeah, definitely we're seeing the impacts of the greater need for energy efficiency, and we're acting on it as well.
And I think extending on that, one of the fantastic things about the water industry is we're a very collaborative industry, but also potentially we can get competitive, but not in not sort of commercially competitive. So there's an organisation called the Water Services Association of Australia, and so they represent all of the utilities, and they do fantastic work around benchmarking. So that brings all the different utilities together to look at things like this, how to optimise your plants, and there'll be various benchmarking programs that the utilities can be involved in, so that they're learning from each other, and that really gives you the opportunity then to share that knowledge and to build and to understand what you're doing and run those plants much more efficiently.
All right, thanks, Daniel and Annalisa. We're moving on to the last question of the set panel questions before we move into some audience questions. This one's a bit of a long one, so bear with me. Water treatment in Australia has largely relied on imported crucial chemicals, which can be problematic if the supply chain is disrupted. How do you think the water industry can be more self-sustaining and reliable in the future if we experience another global pandemic or crisis? So I'll throw this not easy question to Annalisa first, I think.
Well, I think it is a really interesting question, and obviously one that a lot of us turned our mind towards in February and March. To be honest, it's a much bigger question than just water treatment chemicals. that we saw across all of manufacturing. So it does come down to those decisions around how much manufacturing are we doing in country, and how reliant are we on external providers. But it's certainly a sort of global and national challenge in terms of how much do we hold, and how much are we going to manufacture, and what supports are we going to provide for those organisations that manufacture in Australia, because we just do not have the economies of scale that you can achieve by manufacturing in Asia. So there's some really big questions to be had, very much at that national strategic level, about what are we doing to ensure that we have that reliance and the ability to survive disrupted supply chains. But I think certainly the pandemic has probably given the engineers a certain self-smugness against the accountants, where there's been a real tension for doing everything just in time, whereas engineers tend to be super conservative and like to have lots of spares and backups.
Right. And Daniel, did you have anything to add on to that?
No, look, Annalisa covered it quite comprehensively there. All I've got is to say that it is a very real threat, and we lived and breathed it over the last 6 months. Again, talking from experience with the Adelaide desalination plant, we had a production target over the last 6 months to meet, that the federal government had actually funded us to run the Adelaide desal plant for. And certainly when the pandemic hit, we had some real concerns about the availability of some of our key chemicals at the desal plant. Some of them unique to desalination as well. We took actions to mitigate that risk, and we came out quite fortunate. But there was a little bit of luck involved, it did highlight. And I think it wouldn't be too many utilities in Australia that haven't gone back and reviewed their business continuity plans now and supply chains to see where are the weak points in an unprecedented situation like the pandemic.
Awesome, thank you both. We've got about 6 minutes left, so I'm going to jump into the audience questions now. So the first one we've got is from Ashlyn, and it says, what technologies are facing the red light because of perception issues, and how is the water industry tackling these challenges? Sorry, I think, Daniel, it was you that brought up the perception issues, so maybe you can touch on this first.
Yeah, so I'll preface it by saying I'm certainly not an expert in direct potable reuse, but I know in conversations with people in the industry, for instance, we have the technology to meet the health requirements of direct potable reuse of sewage, essentially, which I believe requires something like a log 7 or a log 9 removal of viruses and protozoa, which can only be achieved by a combination of by ultrafiltration and reverse osmosis. So they're the technologies we have that we know can do it. But it's and those with intimate knowledge of the technologies know that the water that comes out of them, is second to none in terms of quality. But it's bringing your general customer along for that ride and convincing them that water is as safe to drink as a water that's been sourced from a pristine reservoir or river, for that matter.
Yeah, this is a real challenge that I guess our industry and our society has. So direct potable reuse is occurring throughout the world, or I guess potable reuse generally. And what is really important is that we move away from the water's history and we start talking about the water's quality. It shouldn't matter where it's come from. What should matter is the standard that it's being supplied at. So that's not something that we as engineers are going to solve. That's a much broader discussion that we should be engaged in. But that is taking the policymakers, that's taking the psychologists, the communicators to engage in those discussions, to really take the community on the journey. So if you look at where West Australian Water Corps has done reuse, they ran a long, engaging process, and they'd set benchmarks for what success would look like. And they took their community on the journey. In this case, it was an aquifer recharge project. But I think it's not so much about the technology, but it's about taking that community on the journey. And that's more than one organisation. That's a whole of government approach to deliver that outcome. And that's what's going to take us there.
Awesome, thanks. The next one's from it's from Coco. This is to Daniel. You've spoken about the challenges of the water industry. How has the COVID-19 pandemic impacted water treatment and the industry in general? So we've sort of already touched on this, but if you had any lasting comments, you can add those now. So I'll start with Daniel.
Sure. Look, one I probably didn't touch on before is the personnel side of things. So certainly in the operating of, the question refers to water treatment. In the operation of our both conventional and desalination treatment plants, we had to look at things like what can be done remotely, splitting shifts. So we, as an essential service provider, if we did have the worst happen and we had a group of our staff infected, did we have a quarantine group of staff that could step in and take up the slack if the worst was to happen. So we very quickly had to adapt to a new way of working, both on the operational side and the management side, to ensure our customers enjoyed a seamless supply of their essential service.
And it's important to recognise that extends beyond the engineering aspect, but I'm sure SA Water, I know United Utilities in Queensland also had to look at splitting the customer service teams, because they needed to make sure that they could continue to provide that if someone in the customer service centre came down and they'd have to isolate half of that team, that they could still have another half still in the office and operating. So it was very challenging to have a look at how you could operate in these circumstances. Some of the smaller organisations took one of their staff offline and essentially quarantined them. And so they acted then as the knowledge base and directed people remotely, so that there was always someone who would be able to go back. Because the key challenge here is not just about that if the first team goes down, but then what do you do once that happens? Then you've got another team, but what if someone there goes down? So then you're actually sort of looking 3 and 4 deep, certainly on the planning side about how you're going to manage. And you start to move to some very interesting planning about what is the minimum level of service that we can deliver. And with some of the smaller utilities, they were really interesting conversations about what assets do you just let go if you run out of staff to be able to do all of the maintenance. And then also, how do you keep the knowledge about what you've got to pick back up again? So typically in things like this, you've got that immediate response, but the much longer term recovery. So we've got to make sure that if we have let things go, that we're still picking that up, doing all that longer term maintenance that we put off before we sort of hang up the coat and say, right, we're done, we're back to normal. So it was a very interesting time for the industry. It is an industry that is used to adapting to changing situations. So the stories that have come out from it have been of remarkable resilience.
Awesome, thank you both. Just being mindful of time, it seems we can't really get through the rest of the audience questions. But Daniel and Annalisa, if you could potentially stick around and answer those in the chat function, that would be really awesome. And I'd just like to quickly thank you both for coming along today and sharing your experience in the water industry and kicking off the today portion of this year's theme. You've definitely shone light on the innovative and exciting sector that is the water industry. And it's definitely an industry that you can fall in love with as you both have. So thank you both very much for sharing that with us. And I am now going to hand over to Emma to introduce the next section.
Thanks for having us.
Okay, thank you.
Thank you both for your insight. So next up, we have a series of lightning talks, which will be 15-minute presentations from 3 of our experts in the resource sector. So first up, we have Dr. Neil Thompson, Managing Director at ITM Power. Dr. Thompson has undertaken award-winning research at QUT Australia and KIT Germany within the Institute for Future Environments. His work in the field of integrated hydrogen energy systems has been regularly published in the USA and Europe, leading to his recent appointment as Managing Director of ITM Power. Since then, he has developed a number of local reference sites for ITM's rapid response PEM electrolyzers across the mobility, industrial chemistry, and power to gas sectors in partnership with key international clients. Today, he will be presenting on hydrogen gas power. Following that, Liz Hallifax will be reflecting on her experiences in industry. Liz is a chartered engineer with over 20 years experience working across BP, Exxon, Air Liquide USA, and Unilever. Following a master's degree in chemical engineering from Cape Town University, she began her engineering career in South African petrochemical company Sasol. In her career, she has worked across 4 continents in different industries, spanning from biofuels, FMCG, to offshore operations, LNG, and chemicals. Liz currently holds worldwide accountability for operational risk governance across all operating facilities at Unilever, working across a diverse team of regional heads and technology experts responsible for various technologies and leading the global digital transformation strategy to manage operational risks. Finally, we will hear from Dan Duffy, an experienced production, operations, and engineering leader in the oil and gas industry. Dan is currently working as the Development Concepts Manager at Santos, one of the leading independent oil and gas producers in the Asia-Pacific region. Dan will be presenting on natural gas in Australia and a bit about Santos and himself. So if you have any questions during the talks, please remember to post them in the Q&A tab, and each of our presenters will respond to 1 to 2 questions at the end. Over to you, Neil. If you'd like to turn your video and microphone on, Neil.
Lovely introduction. So, all good?
Hello, Neil.
Yep, can you hear me?
Yes. Okay. I think Neil doesn't have video on it.
Yeah, no. Well,
okay.
Apologies, ladies and gentlemen. We're up here in the country in Malani on the Sunshine Coast, so very poor internet. So, so much for NBN. But anyway, let's see what we can do in gas. A little quick introduction. We're now part of the Linde Gas group as of 3 October last year. So we're proud to be part of the Linde family, which also includes BOC Australia. I guess one of the things I want to make up front, there's been so much hype around hydrogen in the Australian market that we need to calm down a bit and take stock of what's really happening in Europe and the USA, and learn from best practice. And let's not get carried away as we've done in some of the press recently about gigawatt scale projects, which frankly aren't feasible at the moment. In fact, the last gigawatt or anything close to hundreds of megawatts was actually developed in the 1950s. So it was an alkaline electrolyser at the S1 dam. So please take note of that, ladies and gentlemen. What do? We make the white box that's shown in the middle of that slide there, and we're pleased to make that equipment for people such as Toyota, Shell, and others around the world. Very high standards in the oil and gas industry we have to meet for producing hydrogen site through electrolysis. And basically, we're taking renewable energy and wastewater, preferably, and turning it into hydrogen gas and also oxygen and waste heat. We do 3 things with that. We generally put it into gas networks to decarbonise natural gas. We use it in our mobility fleets, cars, trucks, buses, ferries, I do believe, according to Linde Aviation shortly, and renewable chemistry. We're using that to make other chemicals such as ammonia. I guess, as I said, we've been in this industry working for clients like Shell since 2 decades. I guess the first decade was about R&D and the second decade was about commercialisation. So again, we've got reference sites around the world in power to gas, on forecourt refuelling stations, and now the largest electrolyzers in the world at the Shell Wesseling refinery in Germany. And I guess this slide here just gives you a bit of an idea. People refer to hydrogen as the vector coupling molecule. Unlike an electron, we can reach a lot of industries and decarbonise and also help with the economics of those industries. As I said, we were part of the Linde Gas Group as of October last year, and thanks to their investment, we're building the world's largest electrolyser factory that I would invite you all to post-COVID for the launch. But at the moment, we're all stuck in Sheffield. So, and that's manufacturing around 1 gigawatt of PEM electrolysers a year. So, Chief Exec Graham Cooley wasn't to be outdone by Elon Musk. So that's our gigafactory. I guess very proud of the work that our colleagues are doing, not only here in Australia, but also internationally, working on various codes and standards to make sure that hydrogen is deployed safely, both in industrial and public domain. And I guess one of the things that I found researching this area for about 6 years as part of my PhD was that the particular technology used by ITM is quite innovative in terms of its ability to turn on and off rapidly and basically be used in a safe manner for scale up, ultimately to gigawatt scale. And this stack image here gives you an idea of how compact this is. That's a stack that fits into a 10-foot ISO container. So in the space of 1 decade, they've moved from 10 kilowatts in that footprint to basically 2 megawatts in that footprint. So like solar panels, electrolysis has rapidly increased its current density over that last 10-year period. And I guess now that it's got to a point of commercialisation, these units indicated here are actually so these have been deployed. I'll talk shortly about Australia, but in Melbourne at Toyota Altona and at Brisbane in the BOC Bulwer refinery near the Eagle Farm Airport. Because of the Shell project, they arrived at a standardised 2 megawatt module. So that module you see there on the screen is actually in the 10-foot container, and that's deployed across a gang of 5 in the refinery situation I showed you earlier. That's one. Loves having a hat and a shovel, so plenty of action happening locally here shortly in Altona and shortly in the BOC Bulwer farm where we're releasing the products here locally. I guess this gives you just a exploded view of the configuration of the Shell refinery, and as you've seen, the 10 megawatt units made up of 5 2 megawatt modules shown there in the centre, and then all the balance of plant is external. So as we move up from 2 megawatts in capacity to the larger 10 megawatts, it's a external balance of plant rather than built in. And I guess where we play is in the centre section there in blue, where we're manufacturing the PEM electrolysers, and our parent Linde is making the balance of plant, so deoxy, drying, and also electrical conversion equipment. Now that we've sort of passed the 10 megawatt mark, now we're up to 100 megawatt. There's a number of projects. The Runcorn project, powder gas injection, storing hydrogen gas in a salt cavern, and similarly happening in British Columbia off hydropower, so at 100 megawatt level. And again, we stick to the knitting. ITM manufactures the PEM electrolysers as shown as blue, and Linde takes care of the balance of plant. As I mentioned earlier, the good thing about the PEM electrolysis as compared to traditional alkaline electrolysis is we can turn it on and off in under a second. So this has market benefits for the national electricity market here in Australia, and certainly works to allow greater penetration of lower cost renewables, so more wind, more solar, without upsetting the balance on the grid. So a very useful characteristic for the national electricity market moving forward. And in fact, all of the projects that we've developed, both in the United Kingdom, Europe, and now in Australia, are connected to the electricity market for grid services. So that creates another stream of revenue for the operator to offset the cost of producing the hydrogen in the first instance. And I guess one of the other interesting things is we've seen some projects here in Australia, the Tonsley Park project with AGIG, the Gemina H2Go project in New South Wales, and also the ATCO project in Jandakot, Western Australia, where they're starting to look at how do we inject hydrogen gas into the gas network. Dr. Finkel and the COAG team with the federal government are looking at a 10% injection rate. One of the nice things about gas is the fact that it can store energy for long term. So as opposed to a battery which stores energy for half an hour, hydrogen gas is storing this energy over weeks, days, months, years. And again, as I said, all of the projects in Europe around powder gas are now starting to head towards a 20% decarbonisation target and ultimately 100% hydrogen gas. I'll skip through those. Shell was our foundation partner in hydrogen mobility. So there's a picture there of the Toyota Mirai version 1. We've just had a fleet of the Hyundai Nexos arrive in Australia. So there's 20 Nexos heading their way to Canberra for a new refuelling station. So watch what's happening out of ACT. If you scale up, we start to work now in trains and buses. We recently launched a bus program here in Australia. So a network of 100 fuel cell buses across Australia. So that'll be coming to a capital city near you. And of course, starting to move up into, as I said, trains and ultimately ferries are starting to happen around the world with hydrogen fuel cells. Buses is where we started in London. As I said, we've now released the bus program, and particularly in New South Wales, the state government's committed to transitioning all 8,000 public buses to battery electric and hydrogen fuel cell buses. So very exciting in New South Wales. And ultimately, we seek to look at this as a public station for refueling as well. So we're amortising the cost of those assets across the bus and car fleet. Some of the work we've done in Scotland has implications. There's a new project been announced up in the Daintree, heading towards a microgrid for hydrogen. Similarly here, we're using stranded wind power in the islands across the north of Scotland to convert to hydrogen and ship that hydrogen to other islands for reuse in a fuel cell stack and in mobility for fuel cell vans. So I mentioned earlier the first project in Australia undertaken with Toyota. This is the Toyota Altona plant, the new Centre of Excellence for future mobility. So you'll shortly see some announcements there where you can go and have a look at hydrogen forklifts, cars, trucks, buses. That's really the Toyota contribution to the world as part of the Olympics for next year. Closer to home here in Queensland, QUT, in conjunction with the OC and the Queensland Government's installing a hydrogen refuelling station at the Kelvin Grove campus. And I hope that goes in very soon, because then I can start to refuel my Hyundai Nexo when it arrives. I guess basically we've made a lot of noise about engineering, working with Windy and local partners here. We have a very specific 4-step project to make sure that we have a commercially successful project and also very safe project. So we'd like to think that our clients here in Australia can follow suit and take a 2 to 3 year time frame to make sure that these projects are commercially, technically, and from a public safety viewpoint successful. So I guess our recommendations certainly talking to all stakeholders, and interesting to hear some of our colleagues from the water utilities. We certainly want your wastewater for future hydrogen projects, very important that it's socially acceptable. We certainly explore all opportunities in projects across powder gas injection, mobility for buses and trucks and vehicles, and also any benefits we can derive from the project by helping with grid stability. And certainly, I think when we originally did this seminar jointly with the Engineers Australia and IChemE, we'd like to make sure that trusted members of the organisation are used for the benefit of funders and insurers. And finally, we don't want to add to the hype. So if anyone's undertaking a hydrogen project, that I suggest that working behind the scenes and getting things sorted out from both the commercial and a case viewpoint before any press release is made would be greatly appreciated. And I guess finally, from an investment viewpoint, projects going forward here in Australia, preferring to do them as a toll project where we're selling the gas basically as a service, so $1 per kilo rate, rather than asking clients to invest in projects directly. Money can be spent better on other projects, and leave it to ourselves and Lindy to invest in the projects moving forward. So quite a tight time frame. So hopefully that's 15 minutes, and we'd certainly welcome any questions.
we've just had a question for you since you still have a couple minutes left. So I'll just
Sure.
read it out. So this is from Antonia. So from how I understand it, electrolysis for hydrogen production can usually have different forms of input, either fossil fuel energy or renewable electricity. What are the main trade-offs or challenges when it comes to integrating electrolysis into an existing grid? And also, what is the effect of using a fuel cell to convert the produced hydrogen back into electricity?
Very good questions. So to answer the first, I guess the big challenge is making the hydrogen where the electrical input is lowest cost. And typically that's in a regional or remote location. So we've got great wind assets in Australia. We've got great solar assets, but they're a long way from market. So one of the conventional approaches is to make that hydrogen as a gas when that energy is cheap, and then tube trailer it as a gas to the market. I guess one of the nice things about having a large gas network in Australia is that we can actually use that gas network to transfer that low-cost hydrogen to market. So basically, that's currently the format for a lot of the projects in Australia, making the hydrogen near to the wind and or solar PV assets at a low cost, and then transferring that into a gas network to transfer to the major market. The other alternative is to basically use a liquefier to turn that into liquid hydrogen at the same site, and then trailer that by liquid hydrogen. So the cost per kilo is a lot lower as a liquid than it is a gas. So make it where it's low cost and get it to market either as a gas or as a liquid. Secondly, if the business case requires conversion back to electrons, keeping in mind that a lot of the use of the hydrogen never turns it back into electrons. 80% of the work that we're doing is using the hydrogen as a chemical feedstock or using it as a source of heat. Basically, if we are turning it back into electrons, you have two options: a fuel cell, as per the question, and the byproduct of that is heat. So if you can use the heat, you're actually getting a better combined cycle efficiency, around 70-80%. Whereas if you're just using a straight fuel cell, you might be at around 50%. The other option is burning the hydrogen in a turbine, and certainly there's a lot of work happening in that space at the moment in terms of gas blending for existing natural gas turbines. But also work being done both in Europe and America by GE and others for 100% gas turbines. So that opportunity exists as well as another route back to electrons if they're needed.
Okay, thanks, Neil. We don't have any more questions from your talk at the moment. If anybody does have any questions, feel free to post them and we'll try and get them answered after the rest of our talks. So next up we have Liz. So Liz, please turn on your microphone and join us for the next lightning talk. Thanks again, Neil.
Thank you, Emma. I hope you can all hear me okay.
Yes, we can hear you. Would you like to turn on your video?
I think I'll keep it off just for the bandwidth, just in case my connectivity is not that good. So I'll carry on.
No problem.
Well, thank you very much. And thanks for that talk from Anil. It was quite enlightening on hydrogen. So just to give a bit more context, thanks, Emma, for the introduction. My background is in hydrocarbons industry, right from when I graduated up to now, although right at the moment I am actually working in FMCG. But prior to that, pretty much most of my experience has been hydrocarbon. And I was requested to give this talk. I've been fortunate in that I've worked right across various different the hydrocarbon industries in different parts of the world. So the opportunity is to share the evolution of where we are right now in terms of the needs, demands in the energy sector, and also really focusing on emission control and where we're going in the future. As I am very much part and parcel of digital transformation, I also have included the need for us to bring digital into how we think as chemical engineers. So just going back to what I'd like to touch on, right across the board, we're talking back, but a couple of 20 years back to where we are now. looking at all the different sources of energy that we continue to use right now and where are we going in the future. So I'll touch on the traditional crude refining. As I started my engineering career, was really working with coal and gas to liquids, both in South Africa and in the Middle East. Then we'll switch to clean fuels, and also had an opportunity to do design in biofuels in the US for a couple of years, which was also one of the biggest push in the US to go towards E90, E100. Then back in the Australian context, and that I'll touch on the conventional and unconventional LNG. Where do we stand at the moment? And I'll close off with hydrogen, but I think we've had a pretty good overview on hydrogen, so I won't touch too much on that, but it's just to give a bit of a perspective on where we have come from, what are our challenges, and where are we going with it. So I think needless to say, to contextualize the energy landscape, the Paris Agreement really puts a lot of pressure on countries and companies to act responsible. And right across the board, globally, we see cities, countries taking initiatives, and we're not actually companies stepping forward to put forward drives towards the 2030, 2050 plan in terms of going not just to carbon neutral, but also to carbon positive, which of course does require quite a decent shift in thinking on the energy landscape across the board. Just in my view, summarizing what I see as the hydrocarbon span based on my experience of having worked in different industries. I'll start off with what is quite common for the Australian context, which is the conventional and unconventional LNG producers. As we know, we are a big exporter, and I think all the producers right across the east and the west coast are exporting right across to Asia. However, I think where we stand right now is while unconventional coal seam gas production has streamed quite rapidly, there's still a question, and there's quite a bit of debate about, is it going to be continuously feasible as an economical solution when it comes to how many extra wells do you need to drill for coal seam gas versus conventional gas. So that continues to be a debate. I think there is still an opportunity to really bring about more cost-effective conventional production, and I'll touch more about what I see as the digital twin. And this is where I think it's important as chemical engineers to really step back and start to use the power of the digital transformation, using analytics to really optimize our operations, sweat the assets, because we do have what we have. However, all of our assets are stretched in terms of both energy optimizations, sweating the assets, as well as reducing costs. When it comes to the refining spectrum, I think Australia has seen quite a knock on in terms of refining capacity within Australia. We've had in the early 2000s, we've started to go towards clean fuels, which had resulted in all of the refineries, not just in Australia, but globally, upgrading to a clean fuels standards to meet a Euro 4 and Euro 5 specification. However, with time, Australia has not been able to remain competitive in terms of economies of scales when we compare how many barrels per day we produce in any of our refineries versus refining overseas. This, of course, has resulted in a shift from refining capacity to building more terminals and coming into an import pathways. It does bring about the question, right now we are in COVID, how could we potentially be impacted by supply chain constraints, and how would a country like Australia or other countries who are quite dependent now on importing for fuels, survive this if we were to be impacted to any drastic degree. And this is where, again, bringing back to some degree the need for additional capacity, even if in a smaller scale. But there we're talking about using artificial intelligence and bringing in dark factories to really stir back the opportunity to do refining, but refining may be smarter, even if we don't have the economies of scale. Those are questions that are worth considering. As far as renewables are concerned, I just want to touch on biofuels. This was part of what I worked in quite a few years ago. In the US, there was a big boom in biofuels back in the early 2000s, and right across the Midwest, literally most of the farming crops were converted into bioethanol, which, of course, after a big subsidy by the government, it went through a push and then died down after the whole debate on foods versus fuels started to be challenged, which resulted in quite a bit of need for research, which still goes on at the moment, to look at both biofuels, bioethanol, and biodiesel. However, needless to say, it's not something that we should put aside as something that here in this part of the world we can't reinvigorate, where there's opportunities to look at alternative feed sources for biofuels. It, of course, needs quite a bit of infrastructure changes within fueling stations as well to upgrade to a higher E90 close to E100. We're not quite at that space yet, like in the US, where infrastructure has been changed to deal with high ethanol content, but it is an opportunity. I would say when we talk about renewables and looking at use of biomass, that's quite an established technology. Most operators globally across any industry is really starting to move quite progressively into using biomass for boilers, and that's become quite an established technology over the years. And in the missions and as part of the strategies of companies to become carbon neutral, use of biomass boilers has been one of the initial initiatives across the board, together with, of course, using solar panels where possible to generate their own electricity. I won't talk too much about hydrogen because I think we've had a very good talk on hydrogen, but I did want to, from my work at the moment, it's in a global context. There's been quite a big push in the UK, as they're probably a lot higher consumer of natural gas than electricity right across the board, both for domestic and for commercial use. Quite a bit of work has already started in terms of piloting, and a lot of commercial operators have been brought on board to look at how they can actually start to switch to bringing in phasing in hydrogen and bringing in that boiler capacities to move from dual fuel, which is quite common, to tri-fuel operations. Of course, it does need to be on a demonstration scale piloted, but this is where we are, and quite a big push towards hydrogen. I would say that, there's not, there is, as we have historically, we moved from fossil fuel, the traditional crude, to natural gas, to LNG. Each bit has been one step further towards the CO2 reduction. But to move the needle, to get us across the line, to be at that point where we are moving towards a positive footprint, I will be looking to the more attractive technologies like hydrogen as a step forward. So all of our fuels, all of our energy sectors is quite dependent right across the board on all elements. And it's needless to say, hydrogen is picking up. Still some way to go, but all other refining, traditionally LNG, all still continues to be a big part in playing towards a sustainable future. In closing comments, I'd really like to touch on one of the real important aspects of how chemical engineering needs to adapt to be at that forefront of digital transformation. As while the world is moving forward in digital transformation, it is a very much important part and parcel of how we need to think, we need to adapt, we need to learn to fit in with the world of data analytics, and in three key important roles in the energy sectors. One is to continue to innovate in the parts of the world like the hydrogen industries, to sweat our assets, and this is where a lot of our operators have gone down the path of doing digital twins, which allows more data streaming, allows data to be processed into the cloud, whether it's maintenance related, process related. It allows so much opportunities to optimize, do deep analytics to find opportunities where you might not see opportunities for energy optimization. So all of those perspectives of things that were not actually available to all of us is available through digital transformation, and all of us need to upskill ourselves and think about this all the time. When it comes to smart, I also said the third part that is a challenge and something we need to focus in as within the context of where we live is smart manufacturing. While we have outsourced quite a bit, we need to really start thinking about how AI can really help us to be smart manufacturers. And it's important for chemical engineers to fit into that spectrum, make sure we have the seat at the table to help support the right decisions in manufacturing. I think as all engineers, we all need to enable ourselves to think broader than where we are right now in order to make sure we are reaching our potential. So the key takeaways I would say is that when we talk about the energy balance, where do we stand? Are we moving towards a positive carbon footprint? Are we keeping neutral? How can each one of you support this goal? I would say one of the leading platforms, it is available for all to learn and use, is MIT Sloan have put out an on-roads climate interactive simulation tool available for everyone to use. You can use that in the smallest of contexts of your facility that you might work in one day, or in the broadest of contexts of cities or countries making policy changes. It is there for people to educate and train themselves better about how can we make ourselves more sustainable. We all need to be innovative thinkers. As chemical engineers, we need to think outside the box. Artificial intelligence is here to stay, and it's about how do you fit in with that. And my last takeout to all those chemical engineers who are still studying or going out into the field, build good partnerships and mentors who can actually support you in this in the field of how to establish yourself going forward. Thank you. Emma, over to you.
Thanks very much, Liz. That was really interesting. So next we have Dan. Dan Duffy from Santos is joining us. So, hello, Dan.
Hello.
Hey, bear with us, we just have some connection issues with the audio.
While we're fixing these technical issues, if you did have any questions for Neil or Liz, please pop them in the Q&A section, and we'll go through those in the panel later.
Hello, Dan, could you test your mic for me? Okay, while we're waiting, we've just had a question come in for Liz. So could you please elaborate, Liz, on digital twins and how they are useful? So, Liz, are you still with us?
Dan, if you want to give your mic a try, I can see it's gone green.
Yeah, I'm trying. Can anyone hear me?
Yeah, there we go.
Brilliant. Thank you.
Can hear you loud and clear.
Sorry, that's some small technical difficulties on this end, but we've got them resolved. So I'll jump into the slides now. Thank you, and I'll try and accommodate for my couple of minutes of technical issues there. Thanks everyone for your time today. Look, I've been asked to give a quick overview on 3 topics: natural gas in Australia, Santos as it relates to that, and then a quick overview of my career as an engineer. So, natural gas in Australia, we've heard previously from Dr. Neil around the gas network in Australia, and you can see on the slide here, there is an extensive gas network in both the northern, western and eastern coasts of Australia, almost connecting the whole nation. So, a significant infrastructure investment, providing in general terms power and energy to Australians from the various basins around Australia. And the ongoing shift, as we talked earlier about decarbonising the power industry or Australia, is a shift from coal to gas as a transition fuel. In addition to that, significant liquid natural gas resources in Australia heading predominantly to Asia to displace coal in their industries, predominantly through China and Japan. So, look, very simple overview on the natural gas market. We could talk for hours on what this is, but I think that the key takeaway here from this is significant infrastructure covering most states and most seaboards of Australia, both for export and for domestic use. So about Santos. Look, Santos is an Australian company, 65 years now in the making. The first onshore gas discoveries in Australia out of the Cooper Basin. It has the desire and the aim to be Australia's leading domestic gas supplier. We work in all of the domestic markets, both eastern seaboard, western seaboard, and the northern part of Australia, onshore and offshore. Significant infrastructure position. Our current corporate strategy is focused on 5 core long life natural gas and LNG assets. So in the Cooper Basin, Central Australia, in Queensland, both east and west, New South Wales, northern New South Wales, Western Australia, offshore, and northern Australia, predominantly in the Timor Sea. Additionally, we have a non-operator position in Papua New Guinea. So a quick overview of those sort of 5 core assets. Western Australian assets, predominantly focused on the Varanus Island and Devil Creek gas plants, operating both domestic gas there, and also we have a offshore oil operation in the Niggler Division FPSO. Looking to do some significant expansion work as well in the Bidout Basin off the coast of WA. Cooper Basin, the underpinning asset of Santos, where the company started, predominantly focused around the Moomba gas plant and the associated reservoirs and operations from there. Cooper Basin's an interesting operation, so tight gas conventional, so it produces both gas and also liquids products. Those liquids products head south and are exported from Port Bonython to various refineries or chemical users around Southeast Asia. In Queensland, New South Wales, we have, as Liz previously talked about, one of the unconventional LNG operations in the GLNG plant. Again, a unconventional coal seam gas operation to LNG and exporting that again to Southeast Asia. Recent acquisition by Santos in Darwin, the ConocoPhillips operations from the Darwin LNG plant and the offshore Bayu-Undan facility and platform. So we've taken operatorship of that through those acquisitions recently. And we're also looking at a significant expansion project in the Barossa gas field, which is sort of a circa 5.5 TCF field with a 20 odd year operating life to backfill the Darwin LNG facility. Santos has a non-operated asset position in Papua New Guinea in the PNG LNG operation, which is operated by Exxon. And that consists, and we'll talk about that in a little bit, but that consists of the Hides gas plant in the upstream and then the LNG plant down near Port Moresby, where we export to, again, predominantly Japanese and Chinese customers. So that's sort of Santos in a bit of a snapshot. I suppose about me. So this is just a quick overview about myself. Born in Dublin, my family are Irish. We are married to 4 children, educated at Adelaide Uni doing ChemEng, and I've got some hobbies and interests, but there's some photos of me and the family. So I am a real person. I'm not just a robot. My career in education, Tom, this is a bit of a pictorial I suppose demonstration of my career and all the various roles I've had since finishing high school to currently, across a range of companies and geographies and a couple of industries as well in the early days. But probably the key takeaway from this has been it's been a pretty non-linear career path, certainly not following what I thought it was going to be when I left university. So just, I suppose, very quickly kind of going over the key takeaways. My early career, foundation career, working as a plant engineer or a process control and optimization engineer. So a lot of focus on efficiency, optimization, fuel usage, product spec optimization, and those sorts of things. With a focus of I suppose reducing footprint and enhancing efficiency. I spent sort of the first 5 years or so of my career doing that. I was then very lucky to get an opportunity to go to Papua New Guinea and work on the PNG LNG project, and this is probably a really interesting one, working on a mega project because $18 billion of spend, or I think it ended up being nearly 19 by the time it was done. It was a significant expenditure and a significant amount of work that was undertaken. We had, I think at the peak of construction, nearly 11,000, don't quote me on the number, but I think it was nearly 11,000 across all the operating sites during the peak of construction. So if you think about that, that's the size of a small country town. And as a consequence, all the infrastructure that has to go in with building that. It's not just putting the steel on the ground, but it's also having little mini towns or little camps and airfields and logistics transport routes and all those sort of things that go into that in particular. Then also with Papua New Guinea, the geography, very, very challenged geography, remote locations, minimal infrastructure. So as part of that, we actually had to build one of the largest, or the largest, airfield in the southern hemisphere to get all the equipment in to build the Hydes gas plant up in the highlands of Papua New Guinea. It's a fantastic role. Really enjoyed the experience. It was quite interesting working with a mix of people from all around the world in a challenging location. As we built this project over a number of years. So that was that role. Sort of subsequent to that, then this is what we built. This is the finished product. This is the Hydes gas plant at Hydes, and as you can see, significant infrastructure footprint. Even just the shipping containers in the bottom left of the image. That's just a operational laydown yard. When we were building and constructing it, it was 10 or 15 times the size of that to build the facility. That's what can happen if you put 3 to 5 years of effort into putting these things together. But no mean feat doing that. 1.5 kilometres above sea level in the middle of the jungle. And then this is just another shot, another stylized shot of the plant. In the foreground, you can see the power generation and utilities, and then in the background on the right, you can see the main compressors compressing the gas from the Hydes reservoir and sending it down to the liquefaction plant down at Port Moresby. Subsequent to that, sort of the high of a mega project, came back to Adelaide and did a range of technical leadership roles, in the operation sense, predominantly running teams of engineers and focusing on capital program delivery, day-to-day operations, people management. I had the opportunity then to do another couple of weird and wonderful roles. One doing business transformation during end of 2015, start 2016. We had an oil price or resource price downturn, and as a consequence, we needed to make significant changes to our business. So I led the operational side of that, where we, enhanced value, stripped capital cost out, stripped operational cost out of the business, and returned the business to profitability. And then leading on from that, Santos acquired a company in Western Australia called Quadrant Energy, and I was the integration lead for our operations, where we bolted the two companies together and got all the systems and processes and that working together. And then now into my current role. In amongst all that, though, I did a couple other weird and wonderful things. The first being I was a technical lead for our energy solutions team. So we were mandated to deliver some novel energy projects with a focus of either energy efficiency, renewable energy integration, and carbon footprint reduction. So on this slide, you can see two of the projects that we did. First one being on the right, the Hobbs 1 solar powered beam pump. So that's where we converted some of our wells, around 50 so far, and we're ongoing. I think we plan to spend another $15 million over the next 12 months doing another 50 odd. But that's where we converted crude fuel generators into solar and battery, sort of little off-grid renewable energy powered beam pumps. And then on the bottom, you can see our little solar farm down at Port Bonython, where we're supplementing the grid electricity that we have there with some renewable energy to reduce our footprint further. On top of that, we're also we've just entered FEED engineering design for carbon capture and storage project at Moomba, where we plan to capture the CO2 emissions from that facility and inject them into depleted reservoirs. So that's quite an exciting project. Look forward to seeing that one get done. It's not all normal though, and it's not all sort of it's not all planned work. This is another little project I had involved with. I got a phone call in March after a large earthquake hit the Hydes gas plant that we obviously helped build. You know, got a phone call Friday afternoon, got called by Exxon to say, can you come back to PNG? We need some help. We've shook the the environment's shook the plant to bits, and we need some help getting it back up and running again. So a couple of days later, I was on a plane. You know, 400 vaccinations and a visa later, and up in the Highlands again. You know, trying to make the facility safe, trying to establish what damage had been done and how we could restart operations. So that's basically kind of the summary of that little thing. But that was just one of those sort of weird and wonderful things where 3 months of your life goes past on the basis of a phone call that you weren't really sort of expecting. And that's me kind of done in a sort of lightning round.
Thanks, Dan. We'll save any questions for the panel, which we're going to get into in a minute. But yes, thank you for sharing those interesting projects. And thanks to all of the presenters. You've left us with some great food for thought. I would now like to introduce Eric Bardy, who will be joining our lightning speakers for a Q&A panel on powering the nation for our last half an hour. Eric Bardy is an Adelaide University chemical engineering alumni who has worked as a resources executive in top-tier companies including Exxon, Mobil, Santos and CEUS. He is active in the Engineers Australia College of Leadership and Management State Committee, holds an executive MBA from UNSW, and is also a graduate of the Australian Institute of Company Directors, holding chair positions of both the National Board and Victorian Tasmanian Board for the Dial Before You Dig referral service organisations. Eric is currently the head of operations for the CEUS pipeline, where he has initiated an intern and graduate program, while also reshaping their approach to pipeline maintenance, contracting, and leading innovation in pipeline surveillance. So I believe all of our lightning speakers, as well as Eric, will now be coming together for this panel session. So I'm going to hand over to Antonia to ask the questions of our speakers.
Awesome, thanks, Emma. So yeah, just a reminder to our lightning speakers just to pop your mics on. And I'm just going to start, before we go into some of the set panel questions, with some of the residual questions that we've had from the lightning talk. So we've got one here for Neil and one for Dan. I think there was one for Liz, but I think she might have answered that in the chat, which is nice. So just for Neil, this is from Eddie, sorry, due to COVID-19 causing the supply chains to be strained, how much more will a no-deal Brexit cost the hydrogen bus project in Australia? Also, would developing a hydrogen fuel production site be more feasible than transportation from the UK to Australia?
Thanks for that question. Well, I'll take the first one. I think certainly COVID has affected everyone's supply chain, so it's interesting to see how people have dealt with this. So fortunately, we've been very lucky that a lot of the balance of plant on projects is basically coming from local suppliers. So I guess that's been dealt with, but certainly the core technology itself, the PEM stack, is still being manufactured in Sheffield due to the scale of the gigafactory. So ultimately, we may look at these facilities in Australia for the APAC region, but it really depends on the level of demand. So I think it's a case of act local, think global, mix and match the technology and the equipment as needed. In terms of producing hydrogen, I think we started life producing hydrogen at the fuel source. So I guess doing it at service stations essentially and truck stops, bus stops. But we've since learned that certainly here in Australia, adopting a more of a hub and spoke model where we can actually produce the hydrogen where the electrons are the lowest cost is a better model for a country the scale of Australia.
Awesome, thanks, Neil. And there's one here from Tessie for Dan. Any advice or tips for a fresh graduate? What was your motivation in becoming a process control engineer at the early stage of your career?
Sure. Look, I mean, advice and tips are sort of a hard one because it can be so multifaceted. But I think if I reflect back on something one of my mentors said in my early days, it was lean into the discomfort. So where you find areas that are a little bit uncomfortable, or a bit weird and wonderful, they're probably the ones that where the biggest opportunities are. I think the other thing as well is that certainly in the industry that I've worked in, it's always predominantly around teamwork. That you tend to be more, the sum of the parts is greater than the whole, or whatever the analogy is. But together we can do a lot more than we can individually. So I think that's something that's sort of a bit of a shift from university, where you're so focused on delivering your own individual outcomes, to the workplace, where it's not about necessarily the individual outcomes, but about the collective outcomes. And then on the process control engineer piece, I have to give Mr. Bardy probably a bit of credit for that. He's the one that gave me the opportunity to become a process control engineer in my early stages of my career. But look, it was an opportunity that Santos was looking at around optimization and control and identified need. And I suppose again, I lent into that discomfort when an opportunity came knocking, and loved it for 4 or 5 years.
Awesome, thanks, Dan. So now we're going to go into some of the set questions that we've organised for the panel. Just to reiterate, we've got Neil, Liz, Dan and Eric here. So if you have any specific questions throughout the panel, please pop them in the Q&A section and we'll go through those once we've finished the set questions. So the first question that we've got here is, how has the industry changed since you first started your careers? And this is quite broad. So I think I might chuck it over to Eric to start us off with that one. If his mic is...
Yep, no, I think you can hear me now. Look, I've worked in kind of all, basically the industry end to end now. So basically from upstream, getting the stuff out of the ground, through to midstream at the moment, and downstream, basically refining and actually selling product into a retail system. There's certainly been dramatic shifts in terms of efficiency that have been driven through scale pressure in Australia from overseas. If any company could perform the way it is today, 20 years ago, they'd own the world at the moment. So what's happened is people are doing a whole lot more with a whole lot less. Technology there's been innovation in terms of across the whole breadth of that supply chain, in terms of either being more efficient at actually getting resources out of the ground, through to the way it gets processed, the way it gets transported. People have been willing to take some risks, and they've paid off. There's been a bit of an old guard that moved on. Probably when I was in probably the first part of my career, and the old guard was really sort of old oil. The money just kept on flowing, right? The new guard, which I think I really became part of, and I'm probably part of an old guard now, we're the guys that had to actually try to make a difference in a bunch of organisations as we faced certainly lower crude price, which means lower revenues, which meant that costs came under pressure. So again, being able to do more with less.
Awesome, thanks, Eric. Daniel, Liz, or Neil, did you have anything you wanted to add on to that in terms of how the industry has changed?
I think Eric covered it very well. But
sure, I'm happy to go if you can hear me.
Yeah, Liz, if you wanted to comment, I think between you or Dan.
Go, Liz.
Okay, I just wasn't sure if you could actually hear me. Yes, I think from my experience over the years, there's been quite a dramatic change in terms of how we see energy. We've moved from heavy reliance on crude to gas, to moving to renewables, to biofuels and solar and wind. Now we're moving to hydrogen, and that's really in quite a short span of 20 to 30 years. So I see drastic changes as we're trying to basically reduce our carbon footprint, and that'll be constant evolving as we move progressively further and further down this track on reducing our carbon footprint.
Awesome, thanks, Liz. If no one else had any comments to add, we can move to the next question.
Travel and take difficult assignments.
So the next question is about challenges. So you can answer this, I guess, in terms of your own personal challenges that you overcome in your career, or as the industry as a whole. But the question is, what do you think is the greatest challenge in your field? So I might ask Liz to start us off, if you'd like to.
Sure, thank you for that question. I've seen from my personal perspective, the greatest challenge has been to constantly be in a position to evolve and adapt, because it is a moving industry. So where you don't ever really get used to a comfort zone, we need to be progressive in terms of technology adapters as well as followers, as well as leaders in some parts. I think Australia is fast following as well as being leaders in some elements. For me, I have also, in the recent years, as part of my studies through MIT as well, moved towards, even being a chemical engineer, moved more towards digital transformation and how we really start to use digital and data analytics to really start to sweat our assets, to find sustainable solutions, to optimize. And this has really become part of day-to-day vernacular. And I think as all different types of engineers, we all need to move in that direction as part of what we need as tools in our handy box to pull out when we need. It's just like learning to use Excel. We need to really be in that data analytics space and be able to have the conversation, because that's really where the all industries are moving towards, using the power of analytics to help us be more innovative.
Awesome, thanks, Liz. Neil, did you want to comment on anything at all with your hydrogen experience?
Well, I was only just reconfirming before about Dan's comments about put your hand up for the difficult assignments and travel. So I guess, yeah, both personal and professional challenges across, I think, 32 countries. So yeah, and certainly even traveling in Australia now as a post-COVID option. Do something in remote areas and, yeah, get out of the comfort zone. And as I say, both personally and professionally, but also continuing education, I guess, as an adjunct at QT, I've got to get in that plug. So, yeah, I think we're going, as you're saying, Liz, that moving from chemical engineering, to digital, I moved from electrical to economics, and then back into gas. So it's always good to keep learning and challenging yourself. I think that's probably a key message for anyone starting out.
Thanks, Neil. Eric or Daniel, did you have anything you wanted to add to this question?
Yeah, in terms of challenges for the resources industry, I think they're really twofold. One is clearly the decarbonisation of the economy, which I think is definitely happening, and there is an alignment across the whole of the industry in Australia, whether it's the resources sector or the power generation sector, that is happening. It's just a matter of the pathway to get there. And the second challenge is around maintaining our social license. And I think the community is expecting more and more from any player on the ground, whether you're exploring for gas, producing gas, or transporting gas, or processing it. The expectations of the community are probably orders of magnitude higher now than they've ever been. Social media's had a big part to play in that, and actually being able to combat basically misinformation is difficult in the face of significant opposition where people just run with their emotion rather than run with logic. So I think those two things together basically create some of the bigger challenges for pretty all organisations in this sector.
Thanks, Eric. It's good that you mentioned decarbonisation, because that sort of fits into the next question. It seems that in the energy sort of industry, the buzzword is this transition. We're in an energy transition. We're moving towards something else. And the question I would like to ask is how do you see this transition in Australia, and where are we sort of heading? And more specifically, the question asks, what's going to happen to the mining industry? Because everyone sort of thinks that they'll be the first one to go, I guess, in terms of decarbonisation. So I'm not sure who'd be the best to start on this one, but maybe Daniel or Eric, if you could get us started with this.
Yeah, more than happy to. Look, I think in the mining sector, that's interesting. We are actually already starting to see a shift from coal and diesel usage in those players to natural gas and renewable technologies, and they're starting to move, and they'll only continue to move. I mean, they're the biggest diesel consumers in Australia, certainly on the west coast. But there are challenges with remoteness and locality and access to energy, because the energy doesn't necessarily need to be isn't currently necessarily located where the mine sites are. So there are some logistical challenges to get there.
Thanks, Daniel. Would Liz or Neil like to comment on that?
Yeah, happy to. If you're happy, Liz. I'm just thinking about some of the recent projects, both in Australia and in Latin America, around hydrogen, sort of core activities in mining. So very encouraged by some of the work Anglo's doing in haul trucks, but also some of the work. We've done some great stuff here in Australia in auto haul and things around automation, both trucks and trains. So the power plant, as I think Dan's saying, is really the next stage. So focusing on that port sort of aspect is probably a big opportunity in terms of reducing cost for various commodities. So that's where we're doing a lot of work behind the scenes at the moment. So very encouraged by. So you said mining might go first. Yes, it's going first into new power sources. So very exciting.
Yeah, I'd agree with that. I'd say that mining. I think mining, whether it's hard rock mining or the oil and gas sector, are going to change, but they're not going to disappear. Right? Certainly not in our lifetimes. My personal view is there's probably at least another couple of generations of professionals that will go through the gas sector. Some of you may have seen or heard about the federal government's approach to the energy pathway that they're seeking, which is essentially renewables backed by gas, and that fundamentally makes logical sense, and it's just and it's very difficult to see gas displaced with any modelling that I've seen, any modelling or any other conferences that I've been to. Gas has still got a role to play in 50 years' time, because unless there's some significant breakthroughs in terms of the density to which you can store energy, then it's very difficult to see how you generate power without when the sun doesn't shine and the wind doesn't blow. The hydrogen's very interesting. Hydrogen is something that I think is very real, and again will happen. Again, that just it just needs the experience curve needs. We just need to continue to go up the experience curve, much as we've actually heard already this afternoon.
Thanks, Eric. Liz, did you have anything you wanted to add?
Sorry, Emma, I seem to be coming in and out in terms of being able to hear anybody. I might have missed your last question.
So we're just talking about the energy transition in Australia, and what place, I guess, different resources have in that transition, and how gas will be around for a little while to support renewables and the future of, I guess, mining industries as well.
Right. Yeah, very valid question in there. And I think all different parties and aspects of energy spectrum do feed into the continued sustainable use of energy. I think, as you pointed out, yes, gas will be there to stay. We do have export agreements on LNG right across different countries. How that will pan is still an interesting facet as to how other countries also respond in terms of where they're moving, in terms of nuclear and other sustainable sources. But it's going to be still a mix of different blends of energy sources that's going to support us going forward. And it's going to be both support from the government as well as companies driving forward the sustainability agenda across the board.
Thanks, Liz. So we'll move on to the next question. This is a little bit off script, and it's more my interest, I guess. So we did mention that obviously the transition is something that we can't really just switch to renewables like switching on a light. We need to have fossil fuels to back that up. And I think that's something that gets poorly communicated, I think, to society. And so we do get a lot of misconceptions and different perceptions in the media. And so I was just wondering if we could comment on how important, I guess, engineering or chemical engineering is in terms of communication, in terms of the energy sector, because I think that's one thing that's a bit of a barrier in terms of social license. So maybe we can get Eric to start off on that one.
Oh yeah, sure. Thanks. Look, I think it can be tough being an engineer, right? Right. And all of our training is around what are the facts, use logic, use good basic principles to actually deliver something, right? The unfortunate fact is that doesn't work with the general population, right? You need to, as engineers, what we need to learn to do is actually work with others who have got expertise in terms of communication, to particularly en masse, to actually be able to provide probably a far more accurate picture, so that people truly understand where things are at. And a great example of almost, I wouldn't say sort of miscommunication is, South Australia here we've got the largest battery in the world, right? We've got a grid sized battery, right? And everyone thinks that's great, right? And it does, and I think it's making the folk that built it quite a bit of money. But when you actually look at South Australia's energy consumption, you look at when this thing kicks in, you can hardly see it on the graph. It actually provides a bit of frequency support, but it's about 0.1% of South Australia's or Adelaide's power needs. And yet, when you look at the media hype around it, everyone would have thought that we could have run the whole state for 2 hours on it. So I think our ability as engineers to actually understand that you have to communicate in a certain way, and you actually need to actually work with spin doctors to actually work out how to get the right message across.
Yeah, thanks, Derek. Daniel, did you have anything you wanted to add on to that?
I think extending from that line of reasoning is there is going to be multi-technologies that are going to be needed as part of the transition, and there's not going to be a one-size-fits-all solution. There won't be just a case of, we take product A, we put it into the market, and it'll be the panacea to our woes. We're going to need a hybrid range of solutions, and some of that will be using existing infrastructure and modifying it, and some of it will be new investment and new ideas, new ways of thinking. As an example, when I mentioned previously, is looking at retrofitting carbon capture and storage at our Santos's Moomba facility. So it's an old asset, but we now reduce its carbon footprint by by capturing that carbon. That's one way of potentially achieving it. But that doesn't mean that is the solution that will fit every single application. Same as a battery, and same as solar panels and wind farms. They need to come together in a hybrid solution. And I think the next big challenge after we sort of tackle the power industry, noting that still in Australia the biggest form of power generation is coal by a mile. Bigger than gas, bigger than solar, bigger than wind by almost an order of magnitude. It will be the transport industry, and that one's a little more tougher one to solve, because that's millions of vehicles, billions of vehicles worldwide. But how do you then go from the combustion engine to something different that's an easy and timely transition? Because the cars and vehicles will hang around for a while until people individually can economically afford to transition, and that requires development costs to come down and so on and so forth. You there, Emma? I think you're on mute. Rather than fill in the white space, I got a question here from Gerardo on optimization applicable in the workplace. I'll try and answer that one to fill in some time. So the question is, what do I recommend to have a solid knowledge in optimization that I've seen applicable in the workplace? I think from an operational standpoint, in terms of optimizing operations, I think fundamentally you've got to understand the equipment you're dealing with. You've got to understand the operating envelope you've got. You've got to understand the hardware and all the constraints that exist across it, whether it be a compression system, a pipeline network, a separator, a distillation unit, whatever it is. And that takes a little bit of time. It takes a little bit of understanding the personality of the gear you're dealing with. And then it's about trying to apply some first principles logic over the top of it to say, where can I push this? What handles, what levers do I have? And what are the consequences of pushing that equipment in that direction? Is it lower fuel but higher temperatures? Is it higher velocities, lower separation, higher quality, lower quality, things like that? You need to understand these things, and you need to sort of do a fair bit of whiteboard action to understand, the consequences and the unintended consequences of the moves and changes that you want to make. But fundamentally, it's about understanding what the constraints are, and I think the first bit is to understand all the limits and and why those limits exist as well, because some limits are arbitrary and some are there for safety or efficiency reasons.
Thanks, Dan. Sorry, is my mic back now?
Yep.
Awesome. Sorry about that, guys. So just for time, I think we might go with one more of the set questions. And it's, where in your industry do you think has the greatest potential for innovation? But I think we have touched on this a little bit with Liz covering digital twins and AI, and we have spoken on renewables. So I might extend this to operations as well. So I think there's still quite a lot of innovation that can happen while operating plants. That's just as important as new technology. So can anyone sort of talk on that at all? Maybe Dan or Eric?
Yeah, more than happy to. I think Eric, you're on mute there, mate. But while Eric unmutes himself, I'll chat. I think, look, one of the things around that particular challenge is one, how do you make decisions faster and automated? So part of it's taking the people out. So where decisions need to go through a person or activities need to go through a person is, can I think of a smart way to make a computer do it, or a bit of logic or some automation? And that's kind of been in the industry for a while. I think the next piece now is to tie that all together. And that can align to this digital twin concept, whereby you run things in parallel through a model, or it can be through online understanding how things touch each other. And how you can make these decisions automated so that you're not having to get people involved. That's one particular aspect of it. But I don't know, Eric, have you got some thoughts?
Yeah, look, I think the thing that we that we're only at the start of is the whole Internet of Things sort of expansion, and where you've got large spread out assets, right? It sort of lends itself to cheap satellite technology, which is now becoming available as microsatellites, to actually enable you to actually start to look at your asset in a different way. So, for instance, at the moment, we have to, one of our biggest threats in the pipeline industry is someone digging the pipeline up. And so you actually have to ensure that your easement is safe, and you need to do that fairly continuously. And, the way we're doing it today is still the way they did it back in the 70s, which is you stick a guy in a ute and you drive him up the pipeline. Now, with technology now, we're now starting to explore ways with the Internet of Things. What can we do to actually no longer have to do that and only put the guy in the ute if they actually have to go somewhere to actually intervene? But how do you actually sense what's actually happening across a whole pipeline easement? So that's just one example. I know Woodside have experimented with this as well in their LNG plants, in terms of actually finding very low cost sensors to actually provide a network across their plant, so they actually get a far closer idea of what's going on. And these things are, I think it's probably the most fertile ground for people to look at is how can we apply technology now to our industries that has become awfully inexpensive. So, for instance, leveraging off self-driving vehicles. A sensor for a self-driving vehicle can tell the difference between a sign, a person, a cat, a dog, to guide a vehicle. You can put, and these sensors are, you can buy them on the internet for about $50. You stick them on a pipeline sign, all of a sudden you actually understand who's on your easement at any one point in time. So it's actually starting to think outside the box that actually gets and actually move the boundaries of our industries to actually start to encompass that and actually think about things in different ways.
Awesome, thanks, Eric. Just before we quickly wrap up, there's a question for Neil in the chat. What level of confidence and challenges in the energy industry right now regarding research and development in producing commercial hydrogen? The question's just disappeared.
That's all right.
Hydrogen fuel. Yeah, you can read that one.
Yeah, I mean, look, it's not too far away from what Eric was just saying. That it was just making me think about the fact that we've got a fantastic CRC underway at the moment, the Future Energy Export CRC, which is I guess a joint venture between the federal government, WA and Queensland, really trying to extract lessons learned over 40 years in the LNG industry to apply those to the hydrogen industry to give it a ramp up over the next 5 to 10 years. And IoT, artificial intelligence, learning algorithms, etc., digital twinning is at the heart of that. So I think most of the R&D we need is undergoing in that sort of application engineering space. We've done all the R&D we need on the building blocks. It's more about the system integration, putting things together and looking after stuff in a more efficient way in remote locations. So that's really where we're tending to focus our efforts, I think, here in Australia.
Awesome, thank you. Thanks, Neil, Liz, Daniel and Eric for the panel questions. I'm just going to hand back to Emma now to wrap up the session.
Hi, thank you, Antonia, and a big thank you to all of our speakers, Eric Bardy, Dan Duffy, Neil Thompson, and Liz Hallifax, as well as our water panelists who spoke earlier, Dan Bonini and Annalisa. Thanks all for joining us today. I myself learned a lot, and I'm feeling very motivated and excited to be a part of the future of the resources industry. You seem to have all had very diverse and fascinating careers, and it's been a pleasure to get a snapshot into your lives and experiences as a chemical engineer. Thanks as well to all of our attendees for your engagement and your thoughtful questions. I hope that you found today's session insightful, and I'm sure we've all learned something new today. As for the rest of the summit, we have an exciting schedule planned for tomorrow with a session on sustainability and environmental engineering from 3 till 5 p.m. Eastern Standard Time, same time as today, followed by our exciting student-run virtual trivia night, which will be from 6 till 8 p.m. So hopefully you can join us again tomorrow for those exciting events. Thanks again and have a good evening, everyone.
Thank you.
Thanks.
Thanks, Emma. Thanks, everyone.
Thank you.